In this video, I'm going to take you through substitution method for differential equation. There are situations in differential equation where it can only be solved while you making substitution for some terms. So we make substitution for a term like y over x. So you can make y over x to be equal to v. Once you make it equal to v will be equal to, so I'm going to get, once you get y over x equals v, you realize that when I multiply through, I'm going to get y is equal to vx, right? Once you have y equals vx, my y prime will simply be equal to v. That is, when I differentiate v, then I maintain what? X. So v prime x plus what? I maintain v and I differentiate x, giving me what? 1. So wherever I see y prime in my equation, I'll put this one there. Wherever I see y over x, I'll put v there. Wherever I see y, I'll put v over x. And after I have made all these substitutions, I can then solve my differential equation. Let's take some examples and see how to go by it. So my first example, we are solving xy y prime plus 4x squared plus y squared is equal to 0. Once we have such an equation, you ask yourself, how do I solve this equation? Whenever you have a messy equation this way, you make sure that you make the coefficient of your y prime to be 1. So I have y prime. So first of all, let me divide through by x squared. So we are going to have xy y prime plus 4x squared plus y squared is equal to what? 0. Now let's see something. This one will not be linear because of this y squared here. We also have y multiplying this. Hence, we are not using the Bernoullis. That is where you ask yourself, can I make any substitution? If yes, how do I do? I have this x squared here. I will divide through by x squared. Then what am I getting? This will cancel one of the x, so I'll be left with y over x y prime plus 4 plus y over x all squared is equal to 0. At this point, I can make a simple substitution that my v is equal to y over x, right? And once I get this, you realize that y will be equal to vx and y prime will be equal to v prime x plus what? V. That is the differentiation we did in the previous part. So let's see. At this point, I can make substitutions from this side. My y on x here will be v, so I get v, but my y prime here will now be v plus v prime of what? X at this side, plus what? 4 here. So I'll have plus 4. Then this place is what? V all squared plus v squared equals 0. At this point, I can have v plus v prime x to be equal to negative 4 minus v squared. So once I get this, you know that we need to separate variables because I have v and x. So at this point, what do? I'm to divide through with v, so that this v will cancel this v, and I'll have v plus v prime x to be equal to negative 4 minus v squared over v. So at this point, let's see. This is my v prime. I have v here. So what do I do next? Now let's see if we can separate the variables. So let's see. I have v prime x will be equal to, so at this point I can separate this v that I have here, so that I'm going to get negative 4 minus v squared all over v minus v here, right? So once I separate this v, my v prime x will be equal to negative 4 minus v squared all over v, and hence my v prime x will be equal to negative 4 minus 2v squared over v. At this point, you know this one is the same as dv over dx, right? So dv over dx multiplying x will be equal to negative 4 minus 2v squared all over v, and I'll cross multiply so that I'll get my dv is here, so dv is here, then this expression here I'll send it here. So let's see, I'll have dv times v over, so let me make it so simple and clear at this point. So I want to change variables. I have the x here, so first let me multiply the v here. So I'm going to have dv multiplying x will be equal to negative 4 minus 2v squared over v multiplying what? The x, right? So at this point I can multiply my v dv multiplying x, it should be equal to negative out 4 plus 2v squared, then what? The x. I keep on separating. So at this point I'll just take my x out and I'll take this one to this side. So I'll have v over 4 plus 2v squared dv should be equal to negative 1 over x dx, and I have separated my variables. At this point I'm to integrate both sides, so integral of v over 4 plus 2v squared dv should be equal to integral of negative 1 on x dx. So using integration principles, you know that you are going to make substitution here where u will be equal to 4 plus 2v squared. This will be 0, we get 4v. So we get 1 over 4 ln of what? 4 plus 2v squared. Then this will be equal to, here will give us negative ln of what? X plus c. Whenever you are doing separable, just choose one constant. So at this point, we still continue with our simplification. You know that this is the same as ln of what? 4 plus 2v squared to the power 1 over 4 is equal to negative ln x plus c. This expression here, 4 plus 2v squared 1 over 4 will be equal to e, that is removing the ln, to the power negative ln x plus c. At this point, I'm going to have 4 plus 2v squared 1 over 4. This will be e to the power, this will be 1 over x, right? Because I'll have ln of x to the power negative 1. So will be equal to e to the power ln of x to the power negative 1 multiplying e to the power c. I move on. 4 plus 2v squared to the power 1 over 4 will be equal to 1 over x multiplying, this will be c because it's a constant. So obviously c over x. So I'm going to get 4 plus 2v squared 1 over 4 equals c on x. And at this point, what do? I just need to make v the subject because I'm not looking for v. So I have to take the fourth power on both sides. And it will cancel this, so I get 4 plus 2v squared equals c to the power 4 over x to the power 4. And at this point, 2v squared will simply be c to the power 4 x to the power 4 minus 4, right? So I'll have c to the power 4 minus 4x to the power 4 all over x to the power 4, then 2v squared. I still divide through by 2. My v squared is simply equal to v to the power 4, 4x to the power 4 over 2x to the power what? 4, right? So let's see. Now I have v here. You know I made a substitution v equals y on x. So I'll become y squared over x squared will be equal to c to the power 4 minus 4x to the power 4 over 2x to the power what? 4. So once I have this, I just need to multiply. So y squared will simply be equal to x squared multiplying this. That x squared will cancel x squared here. So I'll simply get c4 minus 4x to the power 4 over 2x squared. And at this point, my y is simply equal to the square root of the whole expression 4x4 over 2x squared. And this gives me the solution, and it's explicit solution for our differential equation simply by substitution. And that is how we do substitution method. Now, let's see another example here. I have xy prime equals y multiplying ln of x minus ln of y. How do I solve this differential equation? To solve this differential equation, now let's see. You know that you have xy prime is equal to y. This is the same as ln of what? X on y, right? So at this point, I can just divide through by what? To make my substitution y on x, I need to get, so here's x on y. So I can divide through by, so first of all, let me divide through by y, so that I'll get xy prime over y is equal to y multiplying ln of x on y all over y. So that this will cancel, so that I'll have x over y prime equals ln of what? X on y. And at this point, I'm going to make my substitution here. So now what is my substitution? As usual, v is equal to y over x, right? So once I have v equals y on x, now to make my substitution here is the same as what? X on y, and so I'll get 1 over v to be equal to x on y at this point. So wherever I see my x on y, I'll put 1 over what? V there instead. So I'll get here 1 over v multiplying y prime is equal to ln of the expression 1 over v, right? Now what is y prime? You know that 1 over v will multiply y prime is always v prime x plus v should be equal to ln of what? 1 on v. So how do I solve this part? I have 1 over v equals ln of 1 over v here. So at this point, I have to separate variables. So let's see. I'll multiply my v here so that I get v prime x plus v is equal to v ln of the expression 1 on v. Once I make this, the next thing to do is to send my v here. So v prime x is equal to v ln of 1 over v minus v. Hence I'll get v prime x equals v open brackets ln of 1 on v minus 1. And at this point, I'll have the v on the x multiplying this x to be equal to this whole expression ln of 1 on v minus 1, like this. So I'll just cross multiply. Then I'll have this expression dv over v ln of 1 on v minus 1 should be equal to, you know, here I'm going to have the x on x. And at this point, the separation of variables. So you integrate this side, dv over v ln of 1 over v minus 1 is equal to integral dx on x. So at this point, this is a simple integration you have here. So how do you go about this simple integration here? So integrating both sides, you know that this will give us ln x plus c. But what about this side? So to integrate this side, you have 1 over v multiplying ln of 1 over v minus 1. So treating what you have here as a unit, you are simply going to have, so let's see, if you make a substitution where you have u is equal to ln of 1 over v minus 1, and you integrate what you have here. To integrate what you have here, you know that you simply have to do what? Integrate what you have here over what you have here itself. And what do I have here? I have 1 minus v over v. Is that not it? So once you have this, you have to integrate. You have to differentiate what you have here. Now, even differentiating what you have here, this is same as v negative 1, this should be 0. I'm going to get negative v negative 2. That is negative 1 over v squared. Is that not it? So these are all principles of integration, which is assumed that you've done before you do differential equations. And the focus of this video is to solve this problem straight away. So let's see. This, as I have here, all over what you have itself. So once you do this, negative 1 over v squared divided by this expression, so it will be times v over 1 minus v, right? So that this will cancel and get v. So let me move straight to the integral solution, which is negative ln of what? 1 over v minus 1, and this will be equal to ln of x plus c, and I'm going to get ln of 1 over v minus 1. Okay, so this side, the 1 over v is separate. I combine it, so it's separate, and for that reason the simplification will be far easier. So this wasn't it that way. So as I was saying, you make your substitution to be this way, ln of 1 over v minus 1, so it's separate. So for that reason you have something like this. Let me make it this way. So once you have this, you should make it u equals ln of 1 on v minus 1. So differentiating this should be 0, and this one is going to give me what? Negative 1 over v squared. Then you divide it by what you have itself, and that will be what? Times v. So you get negative what? So cancel negative 1 on v. You're going to divide it by this expression to come and cancel this v. So you just have ln of this whole expression given as negative ln, here was negative, of ln of 1 over v minus 1, and this is equal to, the negative will move, so you are going to get, when you multiply a constant by negative, it's still a constant, minus ln x. And so this is where we are. So I'll just make ln of 1 over v minus 1 to be equal to e to the power c minus ln x. So this becomes ln of 1 over v minus 1 equals, this will be e to the power c, e to the power negative ln x. Why this will give me c? This will give me 1 over x equals negative 1 ln of 1 over v. So ln of 1 over v will be equal to c on x plus 1. So as I move on, e to the power c on x plus 1 equals what? 1 over v. Right? So this will be what? E to the power c on x multiplying e to the power 1. So you let me make it like that. So I'll have v to be equal to 1 over e to the power c over x plus 1. My v was y over x, right? So y over x will be equal to 1 over e to the power c on x plus 1. So I'll simply multiply x and I'll get y equals x over e to the power c on x plus 1 here. And this is the end of the video. Thank you for watching. Please subscribe to support and don't forget to like and share.